Hi, everyone. Thank you all for coming. My name is Jerry, and today I'll be going over COVID-Q, which is a new data set of 1,690 questions about COVID-19. And this is actually a joint work with Chengyu Huang, Suresh Vaselgi, and Jason Wei. So first, I'll talk a little bit about the problem, which is why we came up with the project. And then I'll go into the specifics of the data set, including how data was collected, cleaned, and annotated. Next, I'll discuss some uses and baselines for our dataset. And after that, I'll go over a quick summary of our work. And finally, I've included a quick dataset tutorial for those of you that might be interested in using our dataset. So what's the problem? Well, pandemics develop very quickly, and because of this, it's difficult to keep people up to date with the most accurate and most relevant information. Reputable organizations have tried to kind of alleviate these concerns by making websites with frequently asked questions that people can kind of access to look for answers to their own questions. But the problem with this is that users might not be able to find their questions, and some common questions might not even be answered. Of course, these problems are very much present during the COVID-19 pandemic. So our proposal is to create a data set of COVID-related questions to find out what people are actually asking about COVID and how NLP can be used to understand these questions. So I introduce our COVID-Q dataset. So we scraped questions from 13 online sources, and all of our questions were collected in May 2020. In order to make our dataset as large as possible, we also manually generated some additional questions. So if you'll take a look at the first and second columns here, you'll see that our sources include crowdsourced websites like Quora, Google Search, Yahoo Search, and Bing, and that these crowdsourced websites had the most questions, and they're at the top of this table here. It should also be noted that these crowdsourced websites are more representative of what kind of questions most people are actually asking. We also took questions from a bunch of official sources FAQ websites. So for example, CDC, CNN, FDA here, and these had fewer questions. And you'll also see that we've marked these sources with a star to make them easy to distinguish. And this table here is organized top to bottom from most questions at the top to least questions at the bottom. So you can kind of go through and tell which sources had the most questions. Again, you can see that we've manually generated 249 additional questions to enlarge in our data set. And that kind of brings our total number of questions to 1,690 questions. So we clean our data set by first deleting unrelated questions. If a question isn't related to COVID-19, we delete it because we want to keep our data set as related to COVID as possible. We also delete vague questions because they require subjectivity to interpret. So for example, the question, why COVID, can be interpreted as, why did COVID happen? Or maybe, why is COVID called COVID? And because there's so many ways to actually interpret this question, we delete it. And we also delete location-specific questions, such as COVID deaths in New York, because they don't contribute any linguistic novelty. So for example, in this COVID deaths in New York, you could replace New York with COVID deaths in California, COVID deaths in Florida, and so on. But all of these would have essentially the same meaning. For the same reason, we delete time-specific questions. So for example, here, COVID deaths in November could be replaced with COVID deaths in December, COVID deaths in January, and so on. And again, these would all essentially have the same meaning. In terms of keeping our data set consistent, we removed punctuation, and we also replaced all synonyms of COVID with COVID. So what that means is that we looked for all instances of other ways of saying COVID. So that's going to be words such as coronavirus, COVID-19, 2019 nCoV, and then we replace them just with COVID. And again, that's just kind of to try to keep our data set as consistent as possible. So here I've boxed the number of questions that we removed for each source after cleaning. And the number here is actually the number of questions deleted after we manually went through and deleted questions based on the criteria I described. So for example, in Quora, 374 questions were removed. It should be noted that this number here is independent of the total number here. So this total number, 675 for Quora, does not actually include the 374 removed questions. And you'll see that questions are most often removed from crowdsourced websites. And this is kind of expected because crowdsourced websites are not like official FAQ websites. And therefore, they're kind of more likely to have unrelated questions or location or time-specific questions. But FAQ websites, on the other hand, have to keep their questions as related to COVID as possible in order to be useful. And that's probably why there's fewer questions being removed for those websites. So in terms of data annotation, what we first do is we group questions that ask the same thing into clusters. So most of the time it was clear when two questions should be grouped, but when it wasn't clear, we used the definition that two questions with a common answer should be grouped together in the same cluster. And note that we don't mean like yes or no answers or short answers. What we're actually referring to is an entire answer, such as something like COVID originated in China. So I'm going to give a quick example of some of our annotations. So here the question, will COVID end soon? And when will COVID end? Would be grouped together because they could have a common answer that would be something like COVID is predicted to end at this date. So basically we manually went through all of the questions in the data set, and each question was compared with all existing clusters. And if it didn't match with any existing clusters, it goes into a new cluster. If it does match, it's grouped with the corresponding cluster. So here I've included the number of question clusters that have a certain number of questions. So for example, here you'll see that there are more than 80 question clusters with at least 2 questions. And you'll see that the distribution is kind of skewed in that there are a large number of clusters with few questions in them. And our second annotation is to annotate question clusters into categories. And we select a category based on what kind of information a question is asking for. So on the right here, I've included all of the question categories. So that would be transmission, societal effects, prevention, societal response, and so on. And in parentheses here is the number of clusters in that category. So for example, there are 27 clusters in the category transmission. There are 23 clusters in the category societal effects, and so on. And the bars show the number of unique questions in that category. So basically, as a summary, I'm going to do this transmission category as an example. So there are 188 unique questions that have been grouped into 27 clusters in this transmission category. And you can go down the rest of these categories and see the distribution for each of them. And just to clarify, the difference between this category annotation and the previously mentioned cluster annotation is that categories are much broader and they categorize what type of information a question is asking for. And on the other hand, clusters are more specific and they group questions that ask the same thing together. So I've reported some of the most common question clusters in our data set here. So in each of these large rows, the top row is the question cluster name, and below that is the number of unique questions in that cluster. And then below that is the category of the question cluster. So for example, there are 28 questions in the cluster pandemic duration, and this cluster is marked as being in the category speculation. Most importantly, I want to refer you to these example questions that you can look at to kind of see how we've annotated our data set. Note that for each of these large rows, all of the example questions are asking the same thing. I've included another table here that gives some examples for each category. Hopefully this is useful for you all to see how we've defined each category. So as an example, I'm going to go over the transmission category. So here the example questions are, can COVID spread through food? Can COVID spread through water? And is COVID airborne? You can see that all of these questions ask about how COVID is transmitted, and so we place them in the transmission category. Similarly, in the societal effects category, the questions are, in what way have people been affected by COVID? How will COVID change the world? And do you think there will be more racism during COVID? These all refer to how COVID will affect society, so they are placed in the societal effects category. You can go down the rest of the table and see example questions for each of the categories to try to get a better sense of how we've defined each category. So our data set after annotations looks something like this. We have one column here for the question, and then we also have a column for the source, and then also one column for the annotation. And first is the cluster name, which is this entire thing here. And then in that, we have the category annotation. So the cluster name is always going to be something like transmission dash or testing dash. And transmission and testing, everything before the dash is actually the category annotation. So some of you might be wondering, if we manually annotated the data set, how can we be sure that it's high quality? Well, okay, we check the quality of our annotations. First, an external annotator checked the labels for each question. And what that entails is that the annotator went through each question in our data set and checked the category and the cluster and the other questions it was grouped with. By doing this, they're trying to make sure that each question is properly sorted into the correct clusters and categories. So after doing this, they brought 31 questions to attention that might need to be relabeled. And out of those 31 questions, 16 of the labels actually ended up being changed. As a second test, we also showed 267 random questions to 3 Mechanical Turk workers. And we found that a majority of the workers, so that's 2 out of 3 workers, agreed with 93.3% of our annotations. And there was unanimous agreement, which means all workers agreed, on 58.1% of our questions. And 99.4% of those unanimous agreement questions agreed with our annotations. And we take this as an indication that our annotations are generally correct. Now let's move on to the uses for our data set. So I'm going to talk about some of the tasks that COVID can be used for. And we have 2 primary question understanding tasks that we've annotated. And first is the question category classification task, and also the question cluster classification task. In the question category classification task, questions are assigned to one of 15 major categories. Note that we don't count the other class. The task is to, given a question, classify it into one of these major categories. So to split our data set into training and testing sets, for each category, we pick 20 random real questions to use for training, and the rest of the questions in that category are used for testing. As a refresher, here's the distribution of questions for each category. You'll see that we picked 20 real questions for our training set because our smallest category that we use, which is symptoms, only has 26 questions in it. After splitting the data set, we end up with 15 question categories with 20 training questions per category, and that gives us a training set size of 300 questions. We also have 668 testing questions that are real and 238 author-generated testing questions. For our baseline, we extracted features from BERT to get an embedding for each question. And we used average pooling after comparing it with max pooling and a basic CLS token, and finding that average pooling outperformed both of them. We don't do any fine-tuning because we're only providing a baseline for other work to improve on. So once we have these question embeddings, we use 2 models. First is an SVM support vector machine, and we also use k-nearest neighbors with cosine similarity and k = 1. We also do some simple data augmentation from this paper here, which includes synonym replacement, where a random word is replaced with a synonym, random insertion, where a synonym of a random word is randomly inserted, random deletion, where a random word is deleted, and random swapping, where two random words' positions are swapped. You'll see that the k-nearest neighbor model achieves about 50% accuracy on both real questions and author-generated questions, and that the SVM performs similarly. However, augmentation did not work very well for the k-nearest neighbor model, but it did improve performance on the SVM by a significant amount. So that's 6% for real questions and about 5% for generated questions. We also plotted the confusion matrix for the SVM predictions on the question category classification task. You'll see that some of the categories were difficult for the model to distinguish. The model had a 34% error between transmission and having COVID, which is this square here and this square here. And it also had a 33% error distinguishing between symptoms and having COVID, which is this square here. So these are the categories that are difficult for the model to distinguish between. Our second task is the question cluster classification task. Here, questions that ask the same thing are grouped into clusters. And the task is to, given a question, find the cluster in the dataset that asks the same thing. So to split our dataset into the question cluster classification task, we only consider questions with at least 4 questions in them. So for each of these clusters with at least 4 questions in them, we use 3 random real questions for training and the rest for testing. You'll see that we have 89 question clusters with at least 4 questions in them. And by taking 3 training questions per cluster, we get a total of 267 training questions. We also end up with 460 real testing questions and 131 author-generated testing questions. For our baseline, we use the same BERT feature extraction with average pooling to get question embeddings. And for our 2 models, we use the same k-nearest neighbor with cosine similarity and k equals 1, but this time we use a triplet loss-based 2-layer neural network from this paper here. And this neural network works by maximizing the distance between an input question and questions from other clusters, and it minimizes the distance between an input question and questions from the same cluster. We again use the same simple data augmentation. And when we test our models, we find that the k-nearest neighbor performs at about 30% accuracy on real questions and 21% accuracy on author-generated questions. Again, augmentation does not yield much improvement for this k-nearest neighbor model. However, we find that for triplet loss, the performance is 42% for real questions and 57% for generated questions. But this jumps to 54% on real questions and 60% on author-generated questions with data augmentation. And that's going to be a 12% and 3% improvement, respectively. We theorize that this combination of triplet loss and data augmentation works well together because they're both trying to teach the model to disregard small differences. In triplet loss, the nature of the network is to minimize the distance between an input question and questions in the same cluster. So it's essentially minimizing the distance between a question and similar questions. For data augmentation, given a question, generates questions that are slightly different but would have the same annotation, which is again teaching the model to disregard small differences. And we theorize that because both of these methods are essentially trying to disregard small differences, we believe that this explains why this combination saw so much improvement. So moving on to the discussion. The primary uses for COVID-Q are that the question clusters can train question answer retrieval systems. And this is a system that, given a question, will look in an existing database to find a question that asks the same thing and will return that corresponding question's answer. There are also some question understanding tasks that our dataset yields. First, because of how categories were created, the categories can essentially be thought of as the topic of a question. Similarly, clusters can be thought of as the intention of a question. And this is because questions that intend to ask the same thing are grouped together in clusters. Our dataset can also be used to evaluate COVID-specific models. Because we use BERT based on case from Hugging Face and we didn't fine tune our model, the word COVID isn't even in our vocabulary as an example. So our model was not specifically trained for a COVID dataset. And so we suspect that specifically trained models will greatly outperform our baselines. There are some limitations with the dataset, and the first is that the COVID pandemic is ongoing, and this has two problems. First is that we don't recommend using the answers that we collected because they could have changed after we collected them. This could be a problem if, for example, a vaccine were to be discovered and our answer that no vaccine currently exists is used. Second, question clusters annotations might change as new questions arise. Another limitation with our dataset is that the question category annotations might seem subjective. But to remain as transparent as possible, we have provided formal definitions for each category that can be seen on our GitHub repository. Our dataset did have some interesting findings. So first is that questions from FAQ websites often did not ask the same thing as any other questions in the dataset. So for CDC and FDA, about half of the questions on their FAQ page didn't ask the same thing as any other questions in the dataset. So what this means is that questions from FAQ websites are not actually being asked that often. Another interesting finding is that common questions were often not answered by an FAQ website. So for example, 54% of question clusters with at least 2 questions from non-FAQ websites remained unanswered. And what this means is that common questions are not being answered. So essentially, some questions in FAQ websites are not being asked, and some questions that are frequently being asked are not being answered. So here we've provided some examples for the FDA and CDC questions that they answered, but were not asked by any other questions in the data set. So for example, the FDA question, can I donate convalescent plasma, was not asked by any other question in the data set. For each of these questions, we've included the 3 closest matches from BERT for each of the example unasked questions. But what should be gained here is that the FAQ websites are including a lot of questions that aren't actually being asked. We've also included some examples of question clusters that weren't answered by an FAQ website. So in each of these large rows here, first is the question cluster, and then the number of questions in that cluster, and then some example questions. So for instance, the question cluster number of cases has 21 questions in it, and some sample questions include, are COVID cases dropping, have COVID cases peaked, and are COVID cases decreasing? What's essential here is that for each of these question clusters, even though they were very common, FAQ websites didn't answer them. So to summarize, we've presented COVIDQ, which is a data set of 1,690 questions about COVID-19. And we've annotated these questions into first question categories, which is what type of information does a question ask for, and also question clusters, where questions in a cluster must ask the same thing. We use these annotations for 2 tasks. The question category classification task, where our max baseline accuracy was 58.1%, and also question cluster classification, where our max baseline accuracy was 54.6%. And we hope that COVIDQ can help develop applied systems or evaluate domain-specific models. For those of you that are interested, our paper can be found on OpenReview at this link here. And we've included a QR code that can be scanned. Also, our actual data set is published on GitHub at this repository. And again, we've provided a QR code for this. I'll stay on this slide for a second for those of you that might want to scan one of these codes. And for those of you that are interested, I'm going to do a quick tutorial on how to navigate our data set. So if you go on our GitHub, at the homepage, you'll see something like this. And primarily, I just want to go over this data folder and the final master data set CSV file. So first, clicking into this data folder, you'll find all of our original documents for each of these sources we gathered. So original CSVs is the CSVs with questions, answers, and sources for each of our sources. And the PDFs is actually a PDF of the website that we scraped each of the scraped all of the questions from for each source. We've also included a copy of the final master dataset CSV file here. And there's also a documentation file here where you can see more specific details about each of our sources. And so that would include information such as the exact URL. And going back to the homepage, if we enter into the final master dataset CSV file, you'll see that it's basically, we have many columns here. And we have the question, we have the source for that question, we have a cluster ID, and then we have the category and cluster annotations. If the cluster has been answered by an FAQ source, we've also included some answers here at the final column. And to go over the annotations again, this entire thing is the cluster name, and the word before the dash is the category annotation. So thank you all for coming. I hope you learned something about COVID-Q, and we hope that COVID-Q can be useful for anyone interested in what people are asking about COVID-19.